Welcome to the StormsurVideo surf forecast for the week starting Sunday, November 9th. First, we'll take a look at significant wave heights for the North Pacific Ocean. The only thing of real interest is the remnants of what was extratropical storm Nuri on the intersection of the dateline and the Aleutians, generating 32-foot seas. Otherwise, a rather calm pattern is in control. Let's take a look at upper-level winds. These winds at the jet stream level, about 30,000 feet, help direct the track of storms when they form and also support their formation. Currently, we have a nice patch of 180 knot winds pushing off of the Kuril Islands, pushing into a bit of a trough here on about the intersection of the Dateline and the Aleutian Islands. This is what is currently supporting extratropical storm Nuri, but the core of that system, for the most part, is up in the Bering Sea with just limited fetch south of the Aleutians. Otherwise, a ridge, that is, the jet pushing to the north, is supporting high pressure at the ocean surface here, and that is keeping, for the most part, the U.S. West Coast high and dry, though British Columbia is seeing precipitation and snow in higher elevations. Let's put this into motion and see what's going to happen here in the next several days. Notice the jet continues quite strong in the 170, 180 knot range into Monday, continuing to support gale formation there, and then sort of backing off, and this trough here kind of pinching off a little bit by Tuesday. But notice the jet sort of comes down, dips here. This is the main trough here, and then again this ridge protecting the U.S. West Coast, but energy moving very close to the coast by Tuesday. We'll roll this out a little bit further. Notice it's almost like there's one trough here, a second trough here, but really it's almost pinched off and the axis is this way instead of straight north and south. So that pretty much puts an end to storm formation. But notice another patch of wind, upper level winds here, 140 knots, starting to ridge off Japan by Wednesday. That continues and continues to feed yet another developing trough in the same location, pretty much north of Hawaii, by Saturday. Again, 150 knot winds, and that just sort of rolls on out. We'll take this out to 180 hours, and notice we get a little bit of energy trying to start to push into the U.S. West Coast. We'll actually roll that back. Notice, so there's the ridge, and the ridge pretty much, and it's almost like there's an upper level front here almost on Saturday, and it actually pushes very close to the U.S. West Coast by late Sunday. Looks like the door wants to open here, but not quite yet. So if we aren't going to have major storms, at least bring on the precipitation, give us snow in the upper levels of the atmosphere. It seems like we're very close to that happening. Let's go take a look down at the surface. So first up, here's the remnants of extratropical storm Nuri. Notice only 35 knot winds south of the Aleutians. And here's the Aleutians here. They are a virtual wall. Any swell generated in the Bering Sea is not going to make it through the Aleutians, is not going to have any impact whatsoever on the North Pacific Ocean. So it's only this sliver of fetch right in here, aimed almost completely to the east, that is the swell producing region for Nuri. In fact, let's go back in time and see how this played out. So here we are almost a week ago. Here's Nuri off of the northern Philippines heading north, and we'll just roll this out real quick. You see it take the track up Japan along the coast there, and then starts to blow up. Here we are Friday, starts to blow up, and here's the core of the low. Here's the Aleutians right in here. So this is Friday 12Z, basically Friday in the morning. By 18Z, the core of the storm right here is just about over top of the Aleutians. And by the evening, it is fully north of the Aleutians. Pressure, this is when it was deepest. This is at Friday evening, 06Z. It was at 930 millibars. It was projected down to 918 millibars, which was supposed to be a record low pressure. A few days earlier, a lot of the press picked up on that. They made a lot of hype out of it. But in reality, the storm did not reach those record lows. And wind speeds. Now, here's the interesting part. Wind speeds, so we're into Friday morning. It was 45 knot winds, and then we got a little patch of 55 knot winds here at 18Z, and then that was it. and then 50-knot winds south of the Aleutians on Friday night, continuing 40-knot, 45-knot winds into Saturday morning, and then it just sort of fades out from there. And the core of it was all basically in the Bering Sea. So this system was nothing special in terms of storm production. We've seen plenty of storms sitting like more down here with 65-knot winds aimed right at the U.S. West Coast. This one was large in terms of aerial coverage, but not particularly, not historically strong. So anyway, here we are, back to current time, surface level pressure, 35-knot winds, little patch of 40-knot winds. Also a notice little cut-off low here, sort of northeast of Hawaii, generating 30-knot winds. And we actually saw that on the wave model chart, but not much of a producer of anything. And falling apart. Nuri, in the meantime, we get into Monday. Continues with this just persistent 35-knot fetch, maybe 40-knot. That's good for 13 or 14 second period swell, but nothing more than that. Then we get into Tuesday. Notice this system here starts to build a little bit. Remnants from Nuri sort of bleed off into it. You get some 35-knot fetch. And then we're into Wednesday morning. Notice this, a nice little fetch of 40-knot winds here. Now, this is all relative to the U.S. West Coast. Maybe some swell production here, maybe some 14-second period swell. And that starts lifting north, and there's more energy behind there. The models have had a hard, they're not sure on whether this is going to all congeal or whether just sort of do a series of small, sort of non-consequential low pressure systems. Anyway, we're into Friday, and yet another low, another low. None of these really get well organized, though. It's 30, 35-knot winds. Here's yet another one north of Hawaii on Sunday, and never really gets particularly well organized. Still, what it looks like is consistent swell production in the 13-second period range for the U.S. West Coast, sideband energy for Hawaii, and that's after all the Nuri thing is, well, actually the swell from Nuri will probably hit about the same time as these are generated, so it's all going to be kind of one big conglomerated mess hitting at different points and sort of peaking and diving off, but yeah, nothing significant. So let's take a look at significant wave heights, and we're back in time here. We're going to do the same thing with Nuri. Watch it develop as it pushes north off Japan. 50-foot seas were what were projected at one point there. Then it sort of died off and continued to work its way up. Then here we are into Friday night. It starts blowing up. Here's the Aleutians again. 39-foot seas, and then we get this one little patch here of about 44-foot seas, but notice tucked right up along the Aleutians. Okay, now here's the interesting part. Relative to Hawaii, you'd say, oh yeah, maybe some energy is pushing down to Hawaii, and in fact it is, but notice the great circle paths are here, and these arrows are almost, probably 45 to 50 degrees off that, so a very limited amount of energy actually falling south. And then, but here's what's actually a little more interesting. Relative to Northern California, notice this particular great circle path here, if you zoomed it in really close, you'd see it. We've got it set up so it just barely is just south of the Aleutian Islands here. So anything north of this line is not coming into Northern California. It's purely into the Aleutians. So what you've got is 40, 41, 42, 43-foot seas on the Great Circle Path and nothing more. The core up here is purely, it doesn't matter relative to California. Relative to Southern California, it's basically the same scenario. There's the cutoff. I think it's about 311 degrees. Okay, so nothing either in terms of the core of the storm. It's all sort of just peripheral energy. Anyway, so we'll roll this out. Nuri continues and just sort of ET Nuri hangs right here around the 308 degree path relative to California. And Hawaii, about the same deal. Now, it's a little bit south of the Aleutians here by, this is Saturday night. Roll that out more, and here you are. You're into Sunday morning here, and the system. This is basically just seas generated from prior fetch. Not a whole lot going on, and it's all but over. You get this persistent note. Remember, we saw 35-knot winds. winds, 30 knot winds. So you get this persistent 20, 22, maybe 24 foot seas there. You know, that's good for 13 or 14 second period swell. Also notice here these systems that start blowing up, not really blowing up, but developing off the U.S. West Coast, pretty much past Hawaii. So here's Hawaii. Great Circle Pass into Hawaii, unless there's fetch actually aimed back, which there isn't here. None of this is interesting to Hawaii, but for the U.S. West Coast, Northern California, yes. Southern California, yes, too, particularly that little patch there if it forms. We're 54 hours out. We're on Tuesday night. Roll this out. This system actually develops pretty nice. What's that, 26, 27 foot seas relative to Northern California? That's about the 295 degree path. That's on midday Wednesday, and relative to Southern California, about the 297 degree path. So maybe something to watch there just because it's so local, not because it's particularly strong or anything. Roll this out. Another little fetch here is forecast off of in the North Dateline region. Not a whole lot happens from that. And yet, here we go, another system in the same pocket here. And notice, remember when you saw the jet stream track, it went down like this, sort of the trough bottomed out here and then would track up this way. And so this is the focus of energy, and that's what we're seeing. And we're 180 hours out, yet another small system, 20 foot seas. Persistent surf likely from that if it all happens, but nothing huge. Interesting. Let's go look at a longer term situation. First up, the Southern Oscillation Index. Difference in pressure between Darwin, Australia and Tahiti. Notice daily negative numbers have been on quite a run. In fact, for the past month, there's almost been a non-stop, unbroken string of negative numbers. This is good. Current values minus 18.26. The 30-day running average, notice it was you know, almost near zero, has worked its way down to minus 13. The 90-day average is good. It's just hanging consistently right around 7 or 8. Here we are at minus 8.7. All this suggests is some sort of a, you know, you'd say a long-term active phase. This is also what El Nino looks like, a weak version of El Nino. The 90-day average, you'd want to see it down about 10 or 12 or maybe even 15 if it were to be a sort of a mid-grade El Nino. But this is just a low-grade simmering fever, barely in the El Nino category, looking purely at SOI numbers. And here's a longer-term look at the 30-day running average. Notice here we are. This goes back about 2 years. We've talked about this in past episodes, so we're not going to belabor the point. The big push in January, that's what got this a lot of the El Nino hype started, but then it sort of backed off. And now we've been in this since July, just steady negative, and here we go. Here's the latest run, down the same level as it was in the January push, and the January push was as same as the false start El Nino that was in July of 2012. So we're actually in a very good place, and look at this, just negative. It's been negative for quite a few months now. That's exactly what you want to see. That really gets momentum going in the atmosphere. That suggests that some change is actually occurring, and it's not a temporary thing. It's more of a long-term thing, that the atmosphere is actually starting to respond to other factors and sort of pick up the gauntlet for some sort of an El Nino event developing. Next, we're going to look at surface level wind anomalies. We want to see westerly anomalies on the equator in the West Pacific. We're going back a little bit in time, November 3rd. Here is the reds are western anomalies. Continues there on the dateline, just a couple of degrees either side of the dateline. Australia, of course, Peru, Chile. Just to get you oriented. So it's this area right about in here that we're most interested in. This is where Kelvin waves get generated. And then on the 5th of November, even a little bit, actually a pretty considerably broad area of westerly anomalies were indicated. And now we go to current time. Again, persistent small area of western anomalies on the 9th has held in this region, right in, and the Kelvin wave generation area is pretty much from about, you could draw a box right about in here to here. And so not a lot, but a little bit. And then we look over to the East Pacific, and again, not a whole lot going on here, just pretty much neutral anomalies. And again, we look a week out now, the 17th of November. Easterly anomalies are forecast. This model, it's a dynamic model, has been suggesting this the entire time. This is the GFS model that's driving this. So easterly anomalies forecast in the Kelvin wave generation area, not a good thing. And then weak westerly anomalies in the eastern Pacific. The issue is, will it really happen? Will those easterly anomalies happen? We're not even hardly worried about, to be honest. The model has been projecting easterly anomalies at different times associated with a supposed inactive phase of the MJO. It's never materialized. All year long, there has literally been no easterly anomalies. We don't believe that this is going to happen either, but you never know. Here's looking over time. Back to October 10th, the reds are westerly anomalies, and again, westerly anomalies help create Kelvin waves, and Kelvin waves are the hallmark of El Nino, or at least is what get it kick-started. And the region that we're interested in is from about 140 east, which would be about here, to about 70 west. So in that region, so we look up the chart, and here we go. There was a weak westerly wind burst in the middle of October, and then things sort of settled down. Supposedly that was easterly anomalies, and here we are now. Here's the little westerly anomaly patch that we've seen. This is off. That's over in the Indian Ocean. So it's this one here and this patch here. And then what the model suggests is easterly anomalies in the Kelvin wave generation area, and westerly anomalies moving into the East Pacific, so we'll see. Now here's another way to look at this. This is the statistical model. We're looking, so here the oranges, so this is outgoing long wave radiation, that is ocean reflectivity. The more the sunlight reflects off the ocean surface suggests decreased cloud cover, suggests high pressure, suggests the inactive phase of the MJO. So this is saying that there's some sort of weak active phase here south of Hawaii on the equator, and an inactive phase developing over the maritime continent. And then it goes basically dead neutral for the next 15 days. Now the dynamic model, which was driving the previous charts we saw, says no, the inactive phase is going to build and basically hold for the next 15 days. We'll see whether that really happens or not. Clearly the models are sort of opposed to each other. One says inactive phase, the other says neutral. We'll see. The 40-day model, again, this is run, this is up at jet stream level. The oranges and yellows suggest areas not supportive of precipitation, which presumably is the inactive phase, the MJO. And this is a dynamic model as well. It suggests the inactive phase of the MJO over the maritime continent working its way east into the 4th of December. So one would say less potential for swell development. And then come about the end of November, the 29th, a new active phase building over the maritime continent, working its way east until the middle of December. This is when one would say, oh, good opportunity for storm development. And clearly, during normal years, storms do go in the cycles. It's on for 3 weeks, off for 3 weeks, etc., and it sort of loops through that continuously, all driven by the MJO. The reality is, when you're in El Nino years, the model doesn't handle things well, and what really happens is you're in this sort of persistent, weak, active phase the entire time, and the inactive phase is never materialized, or at least not as strong as the model suggests, because the models are biased towards a normal year, and they have some problems when you get into this El Nino sort of situation. So our belief is this inactive phase will not materialize or be far weaker than it's projected. And this active phase will probably be weaker too, and it'll just be more of the same, of just basically neutral, biased, slightly active. And then one other view, current. This is actual winds at the ocean surface. Notice a small area westerly anomalies, again here about 150 east. That's what we were seeing on the upper level models. This is actual ground truth data supported by buoys on the ocean surface. You cannot lie to the buoys unless the buoys are down completely. So a little bit of westerly anomalies. That's what helps sets Kelvin waves in motion, or at least gets warm water moving to the east. The normal flow is trades, and here are the actual trades blowing east to west. But notice actually here, we didn't see this before, actual westerly winds are indicated here, not just anomalies, but actual westerly winds. Probably not enough to be a westerly wind burst, but this is what takes warm water in the West Pacific, pushes it at depth, and then it makes its way across and under the ocean surface, gurgling up off the Galapagos. And we'll get more into that in a minute. Next, surface temperature anomalies, ocean surface temperature anomalies. What we're looking for is pockets of warm water. Oranges and yellow are warm. The entire Pacific Ocean is warmer than normal. You can't ignore it. That's been the case for quite a while. But what we're really interested in is warm water here, a couple of degrees either side of the equator, between 120 and about 170. So if you drew a box right there, that's what they call the Nino 3.4 region. That's where you want to see warmer temperatures. We're seeing it. We're not seeing any pockets of cooler water. We're also seeing a building warmer pattern here in the Nino 1.2 region. That the result of a Kelvin wave currently impacting the Galapagos and gurgling to the surface, warming. Notice there's pockets, multiple pockets here of embedded warm water. That's all the Kelvin wave working its way to the surface, trades picking it up, and then blowing those pockets back to the west, warming the Nino 3.4 region. You need, was it 5 consecutive months of 3 months at a time of warming above half a degree for someone to for NOAA to declare El Nino. They may or may not declare it. We don't really care at this point. There's warm water here. There's not cold water. If there was cold water, it's La Nina. That sort of shuts down the jet stream. That shuts down tropical migration or any movement of tropical water up to the north, or tropical air, I'm sorry, up to the north, which would then, and that's what feeds storm development in the winter. When you have warm water here, the trades relax. You get a lot more warm air working its way to the north. Then you got these cold systems coming off Siberia. They hit that warm air, gets sucked up into them. They supercharge, and that really it 1 feeds the jet stream, 2 feeds the storm track, 3 produces more surf, or produces larger seas, which in turn produces more surf, more consistency, more height. And that's kind of what we're looking for. Anyway, lots of warm water here. This looks very good. It's a little bit, the other part is there was a big cool pocket down here, had been for months. It's just getting beat down now. I mean, we're looking really good. We got warm water down here to at least 10 south. I mean, this is not a legit, not a full-on El Nino by any stretch of the imagination, but it's a warm pattern, sort of a Modoki El Nino, and that's what we're looking for. And again, back to this chart, surface temperature anomalies. Here's another way of looking at it. 1, 2 degree anomalies here, but again, this is in the Nino 1.2 region. Out here, it's about a half a degree. And then here is the Kelvin wave generation area, and again, another 1 to almost 2 degrees here. So this is the warm pool that gets tapped by the westerly winds to create the Kelvin waves. This is the Kelvin waves erupting on the surface here, and then going to get pushed back this way. So all in all, pretty warm pattern suggested from this image as well. Of more interest, subsurface anomalies. So this is a profile at depth. Go down 150 meters, 250 meters, and this is the far West Pacific. The Galapagos are right about here. This is the profile of absolute temperatures. Here is the anomalies, differences from normal. Notice there's this channel that starts about here, goes down under the date line. The date line is 180, boom, right about there, okay, and goes then the whole way across the Pacific, and this is just like a couple of degrees either side of the equator, and then gurgles up off the Galapagos here. Notice we have a pocket of 2 degree anomalies here, 3 degree anomalies here, 4 degree anomalies here. This is probably 3 months worth of, it'll take 2 to 3 months for all this warm water already in the pipe, already working its way east to gurgle up off of the Galapagos. So let's say 2.5 months from now, we're talking November to December, January, the end of January, that's core El Nino period. This is the warm supply that would feed whatever El Nino develops this year. Not particularly warm, but not particularly cold. It's definitely warm. We'll take it. That's good news. We really want to see more westerly winds and more warm water. So what happens is the westerly winds blow on the surface here. The warm water starts tracking east and then it falls at depth. It starts falling and accumulates in like these pockets, then works its way down at depth 150 meters. So what's that? About 450 feet down, and then works its way the whole way across the Pacific, gurgles up, and then warms the ocean surface here. So that's what's going on. It looks good. This is a very nice, moderate pattern. Here's another view, same thing. Warm waters falling south, actually at depth, and what is that? 1, 2, 3, 4. 1, 2, 3, 3.5 degrees per this model, working its way up towards the Galapagos. So no real difference between the models. And then surface temperature, surface height anomalies. JSON2 data from November 4th. Higher than normal surface heights. This is strip all the wind waves out, all the swell, all the tides, everything, and just how much difference are the ocean's height here than normal for this time of year. We're talking 0 to 5 centimeters, maybe a little patch at 10 centimeters there. What this means is there's warm water at depth. It's only confirming what we're seeing in all the other charts. Basically, the entire equatorial Pacific is warmer or has warmer than normal water under it at depth. All this says is Kelvin waves are in flight here. We're watching them. This confirms it. So what's all that mean? Well, here's a model. Here's the projection. Right now we're somewhere in around here, let's say 0.6 or so, 0.65 degree anomalies. Okay, forecast to hover under 1 degree through January, even through April, and then start going up. This is just one model. Other models are not nearly as generous out this far. But what the pattern suggests is maybe this isn't really El Nino, it's a Modoki El Nino, which is what they call a weak El Nino, or sort of an El Nino, but not really. But the thought is when you get these Modoki El Nino situations, they go for a year, 2, 3 sometimes, and then ultimately converge on a real El Nino, all the while feeding the jet stream, feeding the global weather pattern, and basically influencing and changing it in a way that is favorable for surf in Hawaii, U.S. West Coast, and also favorable for precipitation and snow and elevation, not only for California, Pacific Northwest, but more on the southerly track, Colorado, New Mexico, and that area, and less so for Canada and the northern tier states. So something to watch. This is kind of what the situation really looks like now. Modoki El Nino. Whether it would actually turn into a full-blown El Nino the following year, that'd be 2015, or the year after that, who knows? It's a wild guess, but the pattern is favorable. Here's a real quick look. Surf heights for, let's say, North Oahu for the coming 7.5 days. Nuri swell, 15-foot range. That might be a little bit overstated, but not too bad. Light winds, a little bit out of the north, though, maybe not favorable north shore. And then a slowly simmering down pattern through the end of the week. And the swell profile, as you can see, swell heights on this chart, 10 feet. That might be a little bit generous in the 16-second period time range, but probably not too far off the mark. Then we take a look at Northern California, a little bit of a swell early part in the week. This is from a previous system. Then the Nuri swell, 10 foot, that's probably about right. 12 foot's probably pushing it. And winds not looking so favorable. Just this persistent north wind, 10-knot thing going on at exposed areas. But still, surf pretty much all week long. And then Southern California, of course, given the rather north angle, we're talking 310 plus degrees, 311 degrees. This is San Diego here. There we go. You can see not as much swell as one would hope for. 3-foot range. That's maybe a little bit understated. Exposed spots will probably do better than that. The light winds, of course. So that's kind of it for the week. But the good news is there is surf, especially if you can get away from shadowed areas. There will be swell, continuous just about all week, and probably into the following weekend if the models hold true. So that looks good. The longer-term projection looks good as well. El Nino, or at least our Modoki El Nino, is continuing to simmer right along. Kelvin waves in flight. All looks good. It's so it looks like the winter will be a pretty decent winter. We're working on the El Nino forecast. We've been a bit sidetracked by other stuff going on, but we are working on that. We'll get that posted hopefully within the next week or so. So that's it. Looks like there's going to be surf. Go get yourself some. We'll do this again next week. Same time, same channel. See you then. Thanks.